Good morning, good afternoon, everybody. Can you hear me?
Yeah, we can hear you. We see the screen as well.
Okay, perfect. Thank you very much. Thank you very much for the nice organization of the event. I try to be quite pragmatic and synthetic. So, here it is. So let's go through the agenda. First of all, brief company presentation, who we are. And I wanted to to highlight immediately what we can do for you and what you can do for us. I mean, it's a wonderful sentence that try to identify and to better explain what we can do. So I want to state this from the beginning and not at the end. In these, we will be focused on examples of what are the potential benefits of high power single mode lasers in aluminum remote welding. Finally, some conclusion. So, first of all, brief company presentation. We prepared a nice video that try to explain who we are and what we do. We started in 1999 as a distribution company. We quickly realized that it was not sufficient providing information related with the specific components, but we quickly understood the importance of having specific related with applications that we are going to analyze. Because of this, the company has decided to invest in a strongly technical way, where each application has some specific engineers that can be focused on this and provide a specific solution to a specific problem. This is an important step. What we are going to get currently is a facility that is the technical name of OPTOPRIM engineering. OPTOPRIM engineering is the division of OPTOPRIM that is taking care of specific applications of each customer. As a market president stated before, it's important for especially welding trying to have a specific need and specific region. So in our facility, not only for welding, but also cutting, painting, casting,
Use the volume of the video quickly.
Given this, the aim is to try to identify the customer the best possible solution. With this object, we try to compensate, to realize an identification of all the process. Okay. So, given these, what we can do for you, what you can do for us is please describe in detail your manufacturing problem. We are going to analyze it to understand the production environment you are located, and we are going to provide you a possible solution for this problem. How do we work and what we do for you? So we perform, first of all, economic sustainability of the idea. We can build whatever we want. But is it really needed a Ferrari to go to the grocery? This is the main question. So if you want a Ferrari to go to the grocery, please, we are happy to help you, but from time to time it is not possible. So first of all, we try to identify the economic sustainability of the solution provided, and then when this is identified, we switch to a technical feasibility. So we identify and we understand the process, we characterize all the process, we select process parameters, we perform pre-production to validate in a more statistical way, and we have a results approval from the customer. When this is achieved, then we switch to the transfer of know-how and of the solution to the machine builder or to the end customer directly. So given these, when all this phase is done, then we will close the project. So we basically, in the OPTOPRIM engineering department, we work project based.
Stefano,
Let's,
we hear you really low. Can you be closer to the mic?
I can try. Can you hear me better now?
Now is better, yeah.
Okay, sorry,
Thank you.
guys. So let's go to some an example of this type of approach. We were asked, always related to the battery field sector, to maximize the working area of aluminum welding plates. Aluminum welding plates were made of 6000 series aluminum that have difficulties in welding. And in addition to this, because of all the problem and all the possible solution available that were also mentioned before, between wobbling, beam shaping, and so on, we were also asked to identify what is better for this type of application. So what we did, for example, for this type of application was a comparison between a wobbling solution and a fixed spot with and without beam shaping. We used one of our cell fully dedicated with different type of remote optics to accommodate specific for each to accommodate each specific optics for each specific application. In this case, we are going to use zoom optics that allow us to work with the multiple lasers. In this case, we compared fixed spot solution with a maximum power of 3 kilowatt, and we will understand later on why only 3 kilowatt, magnification factor of 2, and different type of energy distributions from standard laser, introducing beam shaping. We tested different type of speeds. In a similar fashion, we used always 3 kilowatt lasers, but using wobbling, so using a spot with 150 micron. What we kept constant was the overlapping between subsequent weldings, so from 25%, 50%, and 75%, using wobbling amplitude and using fixing a maximum wobbling frequency of the scanner up to 300 Hz, using the same welding speeds. So if we go directly in this type of approach, we can clearly say that independently from the energy distribution used with fixed spot deposition, in most of the cases we had crack formations. Because of the low power density, in some cases we did not have any welding. Because of the high scanning speed, so we are going extremely fast, we were not able to achieve super high frequency related with the scanner, so we were not able to cover this area, while finally we were able to obtain nice and smooth welding crack-free. So we understand that between these two solutions, for this type of application, we were able to use, it was better to use a wobbling approach. Now, we were talking about single mode lasers, but if you can clearly see, up to now we didn't work with any single mode lasers. So given the identified solutions and given the goal to maximize the working area for laser processes, we worked with this type of configuration, so 50 micron spot, 140 millimeter collimation, and 420 millimeters focus lens, obtaining a laser spot of 150 micron. Nevertheless, the request of the customer in this case was, I want to enlarge as much as possible this working area. So squeezing as much as possible the fiber size, so moving to single mode lasers, and now we understand why we decided to work and to limit up to 3 kilowatt, because currently most of the single mode laser with the highest power can achieve up to 3 kilowatt size. We can keep the same collimation length, but we can enlarge the focusing distance up to 1050 millimeters or 1500 millimeters according to the fiber size, achieving the same spot size. In this way, we can clearly maximize the working area, and thus we can avoid to use a robotics arm and so on, and we can work directly with a fixed scanner. Not only this, but in conclusion, related to this application, not only with this is the biggest benefit, but it is remarked, the last sentence of this bullet point, the fact that with this other type of configuration, we can move the relay length from, let's say, 2.6 millimeter to up to 33 millimeters. What does it mean? That, first of all, we become much less sensitive to eventual focus shift. Secondly, we can be much less eventually sensitive to focus variation of the working plane, especially if we weld thin aluminum foil. And this is a really huge benefit from a practical point of view, in production point of view. In conclusion, we wanted to give you an example of what we can do and how we structure the design of solution that we can provide to our customer. A standard methodology is always used. So first of all, comprehension of the context where the customer is located, and what are the real needs of the customers. Further than this, we identify the best possible solution. Being quite straightforward to an example case that we presented, but we could have had many more, and this is our daily routine. An identification of stable process parameter for welding of 6000 aluminum series using a near-infrared wobbling strategy was assessed, and benefit of the identified process parameter transferred to single mode laser was assessed as well. My main message to all the people here, that I see also some people from the optics side, is that one of the biggest challenges that we are facing is the fact that the limitation of such a long f-theta, long-range f-theta lenses, and also the limitation of high-powered single-mode lasers. We do believe that in the future, in both these sectors, big enhancement will be done and big benefit will be achieved from the manufacturing point of view. Thank you very much.